Welcome to Almost Here, Round the Corner Future Technology podcasts with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more. Coming to Dallas, Texas, September 14th, 15th, and 16th, 2018, the Blockchain and Future Tech Expo. This is going to be a gigantic conference of over 5,000 people. We're going to be talking about blockchain and its applications. We're going to be talking about quantum computing, cybersecurity, artificial intelligence, and several other future technologies that are poised to and actually changing our lives as we speak. Here's why you should attend. As you may know, early adopters are the ones that investigated and profited from things like the gold rush in the 1800s, from the dot-com boom in the 1990s, from the internet boom in 2005, from the smartphone explosion in 2007, from the real estate boom that ended in 2008, and of course, from the Bitcoin boom that started in 2012. Early adopters act now. They don't wait till later. They go out west first. In their covered wagons, they find the biggest gold nuggets. If you consider yourself an early adopter and you want to find the biggest nuggets, then you owe it to yourself to attend this upcoming conference. Blockchain is going to affect how we control and store our medical data, how we send money around the world, how we bank, and more. But artificial intelligence, quantum computing, and cybersecurity will play a pivotal role in our lives as well. And that's why our next event, September 14th to the 16th at the Dallas Convention Center, is going to have not only 5,000 plus attendees, but will showcase blockchain, AI, cybersecurity, quantum computing, and more. You want to get in on the coming gold rush of future tech and opportunity as an early adopter. Don't be left out. To register, go to bftexpo.com. That's blockchainfuturetechexpo.com. Thank you.
Hello, and welcome to the Future Tech Podcast. I am Alan Thomas, and today I have with me Dennis Nobelius, CEO of Zenuity. How you doing, Dennis?
I'm doing fine, and thank you for having me on this podcast.
Oh, no problem. Let's get right into it. What is Zenuity, and what do you guys do?
Zenuity is all about making self-driving car real. So we are focusing totally on software. We've been around for 1 year, and we are created by the safety leaders in the field. So we are 50% owned by Autoliv and 50% by Volvo Cars.
Oh, okay. And what drew you to this company? How did the company come about?
Well, it got started as an idea, and I think that idea started at Volvo Cars. Think about self-driving cars requires a different kind of talent pool. It requires immense efforts, and you need to combine the knowledge from a tier one and an OEM. I think that was the realization. That was 2016, or actually the idea started a bit earlier, but 2016 it became real. And then I got a call. Then at that time, I was then the managing director of Volvo Cars in Switzerland for the market and sales. So then I got a call on the last day of vacation, asking me if I would like to be, probed as a potential CEO for this new company to be created. And that was a dream come true. Being able to actually start a startup, but from experience based and persons that know the game, and get going with these two founders. So that was how it was created. And then we got going legally as of April 2017. So almost 1 year, a bit more.
So you were able to have the experience of a startup with a little bit of kind of a high-powered company behind you.
Yeah, exactly. So the point was that we started with all the intellectual property from all the cars and Autoliv combined. And we got the persons that created those patents to join the company from start. And at the moment, we have added talent pool on top of that. So we have like 1/3 from Autoliv, 1/3 from the OEM, Volvo Cars, and then 1/3 from startups, software industry, telecom, and what have you, then to bring to the knowledge base and get going. So now we are close to 600 persons in like 5 locations in the world.
And so what would you say is the ultimate mission statement for Zenuity?
We have it as a tagline, make it real. And I think that's what we are going to do. So So elevating people's lives by creating inspiring technology for safe and intelligent mobility. That's our internal vision statement. So what we are doing is that we're bringing self-driving technologies to the road as a commercial product out to people to actually access and acquire or lease or whatever they would like to use cars in the future. And so we have a pretty strict deadline on what we are going to achieve. So that's clear for us.
And so is your initial focus on commercial applications or straight to the consumer?
Straight to the consumer. That is our. So we actually, by 21, then we will have self-driving technologies in a Volvo car. That is for sure. And we also expect to have, and we also have some other OEMs as customers as well. And we take a little bit different approach if you compare us towards Uber or towards Waymo or maybe Apple. Let's see. So what our approach is that we develop industrial software. So we develop software and do that for specific customer use cases. And we do it with industrial sensor set. So we believe that we can have commercially available products that you actually can access and buy within a normal kind of car budget, if you will. And we take it on from two different angles. The first one is that we say, all right, let's solve the highway commute. That is on top of the consumer research that we've been doing. Everyone says that commute is really boring and takes a lot of energy away from your day at work. So we've solved that specific use case on highway daily commute. So that's it. And then we take it from the other angle as well and say, all right, parking is also an area which is not so fun. And that's also when a sensor set similar to the highway commute can be useful. So then we also approach it from a low-speed urban driving case, if you like. And then we have a third one, which we also say that one seems really boring. And that is when you end up in queues. And that's actually the first one that we're going to launch. So traffic jam pilot, we call it. So that's when you have cars all around you. And the shift that we do is that we then move the responsibility away from the driver to the OEM and ultimately to us. So those, you could say, are our three use cases that we solve to 99 point very many nines, and being able to put that safely out on the ground in cars. Now, I was just going to conclude them. So the difference versus Uber and Waymo on those is that they are solving the robot taxi problem. So from my understanding, if I speculate them, to remove the driver from the car. And by doing so, they have a perfect business case that makes a lot of sense. But then you need to solve all the situations and all the complexity of an urban driving environment to make that a viable product. And that's a different approach, because then you need to solve all scenarios at one go until you have a final product. And from our case, we solve specific use cases one by one, and thereby we get to a product.
And so the main benefits for the actual users will be to kind of get that time back and not have to deal with the actual stress of the traffic and just kind of make more out of their time, what would normally be their drive time, correct?
Exactly. So you would actually, you would still have the driver behind the wheel, but you will give time back, and you will also, of course, increase quite substantially the safety on the road, because we'll use the sensors. They are operative in operations all the time. So we'll also use them as driver support technologies, and that will be improving substantially the safety on the road.
And so will so when the first models come out, will the main focus be on large urban centers, or does it need to be in rural areas first and kind of move inward, or how does that work?
Let's see how we define the detailed rollout plan, but for sure where we start is where we'll have good and viable HD maps as a base to localize the car. So we'll take it on we call it operational design domain. So we start with a confined, a bit more structured process, so to say, and then as we go, we open up that operation design domain, both in terms of speed on the highway, as well as geographically on where you can actually apply these kind of technologies. And then I'm talking about the highway commute. For the traffic and pilot, that one works immediately from day one globally on any kind of street or situation.
And so in pulling this project together, what are some of the difficulties that you and your team have run across in trying to get this prepped and ready?
That's a good question. I think functional safety is probably the top one. That is, how do you design the entire system with 20 plus different sensors and 3 different redundant technologies? How do you design that kind of system so it's functionally safe no matter what happens. If a brake cord is cut, or the power goes out, or any kind of these situations, how can you design it so it functions safe and can be as safe as in riding a bus? I think that is a good comparison. So it should be on that kind of safety level. And how can you prove that, validate it, and secure that you have designed that kind of system? I think that is the trickiest part. And then, of course, there are more things. Sensor performance is one, for sure. Maybe the robustness and reliability of the LiDAR is one area where it's happening a lot at the moment. And then, of course, you have the compute and the processing capacity and capabilities, both to have an energy efficient compute platform and designed in a way so you can actually run the different virtual software in different cores and secure thereby that you are functional safe. So that's a few of the challenges. And then, of course, you have on top of that, you have all the corner cases, those extreme cases that never should happen, but you need to simulate and realize that your car actually can behave properly in all those situations. A lot of complex problem solving and sensor performance in combination. That makes sense?
Oh, yes, it does. I was just thinking that probably one of the main issues that you would have to deal with is kind of being able to program in that sense of driver judgment, right? And let's say in bad weather or really hot, dense traffic situations, that kind of thing.
Yeah, absolutely. I think a lot to put up, a safe box, precautionary safety, kind of a box where you're safe and you're constantly having a route where you can take as a car, which is safe. And if something happens, you always save that kind of last safe action in the car. So if something happens, the car acts according to the last known safe route to either to a stop or a steering maneuver or similar. So absolutely.
So the car itself will actually be able to learn, in a sense, and kind of improve over time, right?
Yes, when you're going into artificial intelligence, and that's a huge area, and it's kind of the way that you design software in the future. It's like software 2.0, but from a start, what we look at is from a start, and we look more into object identification and free space detection and these kind of areas where it makes a lot of sense to run neural networks, because it's also quite heavy to run them. We do not today see that we use artificial intelligence for driving policy. That is how you decide as a car where to go. That could be within this kind of boundary box that I was talking about before. If you define that with more traditional algorithms, and then you can have the AI to work inside that frames, then it could work. But just to let the car loose on pure AI, that I do not really believe in the next coming years, at least, to be a viable way of showing that you're safe.
So let's talk about a couple of the big wins or main achievements that you feel like you guys have gotten these past few years. I know you said that you're not quite at the launch point yet, but I'm sure there have been some big wins where you've gotten over some serious challenges and you felt like, yes, we're really on our way now.
Yeah. I mean, we could take the starting point, and then I go more into the ADAS domain, as we call it, the advanced driver assistance technologies. So the team, and I'm referring more to the Volvo history, they actually managed to put in production the Volvo XC60, which received the highest active safety score that has ever been measured in the Euro NCAP, which is a neutral safety agency that is measuring all the cars. So that was one major thing. And I also believe that Volvo Cars has put the active safety as standard on all the cars, which is really showing great achievement when it comes to, crashes, avoidance of crashes and support for the driver. So I think that was before the Zenuity was created.